Yeah.
You want to start with 15 or do you want to start with 16?
15.
Let's start with, the reason I want to start with 16 is because there will be an intersection. On 15, you've got horizontal and vertical lines that intersect the line, so you should know your x and your y coordinate at those intercepts for the diagonal line going through. So I'm going to start with 16 and build off of that. Or not.
That's very loud. Like I dropped off the section.
All right. We've got our objective function. We've got our constraints. We know it's a first quadrant problem because you have x is greater than or equal to 0, y is greater than or equal to 0. I also know that my first graph is going to have intercepts of 7. So I started out with my intercepts in the first quadrant. And I know it's looking for everything that is 0 greater than 7. No, it's shading outward. It's shading outward on this one. After that, I do my intercepts for x and y again. I have 4 for x and 20 for y. 10, 20, whatever. It's multiple. And also, it's shading outward. So I have this point right here. So if I highlight where this is going, will there be a maximum on this problem? And why is there not a maximum on this problem? It's not close. Good. There's no lid at the top. All right. So I know that there's no maximum. But I still have to figure out what my minimum is. Now, I see that I have 2 coordinates wind up on the x and y axis. Those ordered pairs are going to be easy to find. It's 0, 10, and 7, 0. So there's 2 of them, 0, 10, and 7, 0. In order to get the other ordered pair here, this is the point at which these 2 equations intersect one another. So what I'm going to do is just set it up with some quick substitution. Say x is equal to 7 minus y. Is that all right by just saying that? So if x is equal to 7 minus y, when I substitute in, I'm going to get 5 times 7 minus y plus 2y is 20. Remember, when you're solving these systems to find the intercepts, get rid of the inequality symbols. Just use equal here, all right? So you get 35 minus 5y plus 2y is 20. Moving things around, I get negative 3y is negative 15. Y is 5. So y is 5. And when I substitute in for x, I get 2. So I check those 3 values. You get this? You can see that you're proud of yourself. Way to go.
Wait, where'd you get the 2?
I substitute into here. Once you figure out one of the y values, you just substitute back into either equation to find x, because it's going to be the same value. Just pick the easier one.
All right.
Something plus 5 is 7. That's something's 2. And then you just use your constraint, your objective function, negative 2 times 0 plus 10, negative 2 times 7 plus 0, and negative 2 times 2 plus 5. The result is 10, negative 14, and 1. Which one's your minimum? Very good. My minimum occurred at 7, 0. And that's how that looks. We find the intersection of the 2 lines. Connors, what do you got? No. You got to do the intersection. What, and guess?
Yeah.
Don't guess and check. You'll be there forever. Do the math. It's easier. All right. Mom, what do you got?
Alright, so it's not a different problem. So for 15, it says whatever is 5x plus 6y is less than or greater equal to 20. How does it even make sense if 0 or x has to be less than 60 and y has to be less than 45 or equal to?
It just tells you it's first quadrant.
But when you divide those out, you get like 80 and stuff.
It's okay. Don't worry about it. Don't worry about it.
Oh.
Your boundaries. You're between 0 and 60 for x, right?
Yes.
You're between 0 and 45 for y, right?
Yes.
Okay. So this intersects at 60, 45. We agree? The other one, as you bring it through, is you divide out, what do you get, 84 and 42? Or what were the intercepts here? It's x is 84, right? So x is 84. And then y is 70. Now, as you look at the way it goes, yes, sir?
Oh, no, it's
Oh, it was the same problem? Oh, okay. As you go through this, do you agree, as you look at your shading, you were bounded in this way, and now with this line, it brings you in here. All right? So now you're looking at 1, 2, bless you. Now you're looking at 5 points, 5 ordered pairs. All right? And it's okay that those intercepts are outside the boundaries of the x and y, because I don't care what happened out here. I'm looking at what happens when it gets inside the boundary. Looking where that line crosses the boundary. Now I know where the boundary wound up, because as I go through my ordered pairs now, this is at 0, 45. This is at something, comma, 45. This occurs at 60, comma, something. And this is at 60, comma, 0. And obviously 0, 0. In order to figure out what those two unknown values are, bless you, all I have to do is substitute in, well, I know that the x value at this point is 60. So 5 times 60 is 300. 420 minus 300 is 120. 120 divided by 6 is 20. And I do the same thing for the other one. 6 times 45, 150? I don't know. No. 250. What is it? 270? So it's 270. 420 minus 270 is 150? I don't know. I can't do math in my head. I'm surprised that I did that one right. So it's 150. So 5x is 150. So x is 30. Do that one. So right there, you're testing those 5 ordered pairs to find your maximum and minimum. That's how you are finding where these things are crossing each other, by rough sketching out these diagrams. Remember, it doesn't have to be perfect. It's not going to look flawless. What you're looking to do is get a visual representation of where things are crossing. I know my slope doesn't look right. I know my scale is nowhere near perfect, but I do know that this line, 5x plus 6y, crosses through here. Because 84 is bigger than 60 and 70 is bigger than 45, just by connecting the dots, it shows that it crosses at those values. It's just a matter of figuring out the sets of the ordered pairs. All right. What's the other one you want to look at? Which one? 20? 19? 19? Come on, don't you want to jump into the orange aid? Orange, you glad you came to class today? All right, so x is greater than or equal to 0. Right off the bat, if x is greater than or equal to 0, you know you're either going to be in first or fourth quadrant. Do you agree? All right. So I'm just going to rough sketch. Just that, just to start. Cover and solve for the second one. X-intercept of 3, y-intercept of 2. And it's going outward. And I know it's going this way as well. Cover and solve again. 3 and negative 4.5.
I don't think it's negative.
I got negative.
But remember, this line does continue though. Is 0 minus 0 smaller than 9? Yes. So it is going in here. I'm not shading inside here anymore because I know it can't be below that first inequality. Are you guys okay with that?
Yeah.
All right. You kind of went, all right. And then lastly, I have intercepts of 20 and 4. And it appears it's moving inward as well. So I've got this funky looking four-sided figure. Thank you, sir. Got this funky four-sided figure. It may or may not be a trapezoid. I don't know if they're parallel or not. But I have 4 ordered pairs. 0, 2, 0, 4, 3, 0, and this one. That ordered pair, I have to figure out what 2 lines were that they intersected. Well, it was these 2 equations that intersected each other. Do you agree? Bless you. Since it was those 2 lines that intersected one another, I just have to solve the system of equations to figure out what that ordered pair is. Now, like I said, we can do this many different ways. One of the ways, I'm just going to go ahead and just use substitution again, because I have an x variable by itself. I know that x is 20 minus 5y. I'm just going to write it like that. Okay? Substitute in 3 times 20 minus 5y minus 2y is 9. 60 minus 7y is 9. Nope, not 7. 15. Minus 15 minus 2, so that's 17y. Do we agree on that? What is that? 50, negative 17y is negative 51. Is that 3? So y is 3. If y is 3, 20 minus 15 is how much? 5. So this ordered pair is at 5, 3. Those are your 4 ordered pairs if you check for your constraint. Did I lose you? Where?
Well, I just compare it to my
It's easier. Sometimes it's easier to visualize when you have that, so we don't miss all your order pairs. So okay. All right. Yes, sir. Here. I solved where these 2 lines intersect. I had to figure out where these 2 intersected using system of equations. What we did last week. Because those are the 2 lines that I drew. The one with the 4 and the 4, the 4.5 and the 3 came from this one. The other one was the 20 and the 4. That was this line. So I was looking at these 2 lines where they intersected one another. They intersected here to solve, to figure out the intersection points, you have to solve the system. Yes, sir.
In order to find the minimum maximum, you just take every point where the area changes?
Correct. You take that shaded, see how we have that shaded region in here? You take where they change directions. In this case, since you can see that there's 4 sides, there's got to be 4 points. Yep. Yep. You take those 4 ordered pairs, go on the objective function and go. All right. Hold on to this one for now. That way you guys know how to fix it for later. I do want to get into the word problems. I want to try a couple word problems with you guys on this stuff today as well. All right. So if you are completely lost on what you did, now you've seen a couple more examples to continue. But I want to give you guys some starting points for word problems. So, I'm going to start with the gift basket problem.
Oh,
Because you guys look like you need a present. Yes, ma'am. I can't count this. So here's what happens. Don't worry about scientific notations.
You're talking about shifts.
The gift basket problem. To start with the gift basket problem, what we want to do is read it. I do all these too, so I can make sure I reread them. You're making a gift basket for your mom. How sweet. In the problem, it tells you that you are going to give her hardcover and paperback books. You have $80 to spend. Each hardcover costs $24 and each paperback costs $8. The basket holds at most 3 hardcover books and at most 7 paperbacks. Find the maximum number of books you can include in the basket. So, when you're reading this problem, do you guys all agree that they're talking about maximizing the number of books?
Yes.
Is that your objective?
Yes.
Okay, that's the first thing you want to try and decipher from these types of problems. It's usually one of the last sentences. Find the maximum blah, blah, blah. Find the maximum profit. Find the maximum number of things, what you can do. So, they're talking about find the maximum number of hardcover and paperback books. I'm going to write that as my constraint, or my objective function. I'm going to continue to use the letter C for that, equals hardcover plus paperback, H and P. All right. Also, in this problem, did they discuss money?
Yes.
How much money do you have to spend? You have $80 to spend. Can you spend more than $80?
No.
No. So if you can't spend any more than $80, it's just going to be blah, 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 less than or equal to, blah, 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 greater than or equal to. Less than or equal to. See how I'm starting at the right side and working my way to the variables? We've already defined that we have a hardcover and a paperback book. How much is each paperback book?
$8.
And hardcover?
24.
So 24H plus 8P has to be less than or equal to 80. Is there a cap or a parameter facing each of the other books? At most 3. So, excuse me, at most 3. Is that a greater than or equal to or less than or equal to?
Greater than.
So it's got to be, that was what? H has to be less than or equal to 3. Can I have 0 amount of H?
Yes.
Can I have less than 0? No. So I know that I have to have, it has to also be then greater than or equal to 0. Do you agree?
Yes.
All right. Same thing with the paperback. I can have at most 7. So the paperback has to be less than or equal to 7. But once again, can I have a negative value of paperback books?
You may not.
I may not. You just made a constraint problem. It's not as bad as it looks, is it?
I would have never gotten that.
But yeah, no, this is the first time you've seen it, but as you start to get to the next problem, they're all kind of the same. You try to identify what your objective is first, and then you look at it, are you talking about money? Are you talking about time? Are you talking about pieces? Do you have maximum values, minimum values? At most, at least, that's what you're looking at, being able to pull out from the information. So from here, it's just a matter of, let me go double screen here. And we draw our diagram. Do we agree it's going to be a first quadrant problem?
Yes.
All right, I know it's first quadrant. When you do these things with different variables, label your axis, H, P. That way you don't mess things up.
Yeah.
It doesn't matter. I usually go with whoever one I write first is the X, the second one is the Y. If you go alphabetically, you can do that as well. It really doesn't matter because as long as you're consistent, it's going to be correct. All right. Just start with your stuff. I know that H has got to be greater than or equal to 3. Oh, sorry, less than or equal to 3. So I'll move this over a little bit. Call that 3. And it's got to be going between here and here. Same thing with the 7 for the p-value. And it's moving downward. Where those two lines intersected, what's the ordered pair? 3 7s, good. So I'm just starting by putting in one of them that I know right away. And now I do my intercepts. For the P, intercept is 10. Do you agree? And the other one, 80 divided by 24 is 3 and change, right? Yeah, so it's 3 1/3. So it's more than 3? Like here? Does it matter where it is?
No.
No. Because now I do this again. And I've just created 2 more points I have to solve for. So, in order what I have to check now is, am I shading inward or am I shading outward? Am I going to the 1, 2, 3, 4, 5-sided figure, or am I going to that 3-sided figure?
The 4-sided.
5-sided one. Because 0 plus 0 is still smaller than 80, so I'm working in here. So we've defined this area to be the region that I have to check. We already know 3 of the endpoints. 0, 0. So my endpoints that I'm looking at, we have 0, 0, 3, 0, 0, 7, because those are the 2 intercepts on the sides. Now, in order to figure out these 2 guys, well, what's the x coordinate at that point? 3. What's the y coordinate at that point?
7.
So 3 times 24 is how much?
72.
Very good. 80 minus 72 is what?
8.
8 divided by 8 is?
0.
1.
1.
And I love the fact that you're going 0, 1. Same thing. 8 times 7 is how much? 80 minus 56 is how much? 24 divided by 24 is? All I did was just substitute it and solve that out. Obviously, you can write it out, use your calculator or whatnot. I figured it's just as easy to talk through this one. So what do I do with those 5 sets of ordered pairs?
You add it into the C equals R.
Yeah, I check them into my objective function. 0 plus 0 gives me 0. 3 plus 0 gives me. Where am I going to get the biggest bang for my buck, if you will? 1 7. 1 7. 1 hardcover.
7 paperback.
And there's your max. That's how it works. But then you don't have enough money. So bigger basket, yeah, smaller basket would make it look like you have more stuff in it because you're restricted on money you spend. Because if you have a real big basket,
Or you buy more books.
Then again, you just bought a big old basket.
let's look at the next one.
What is this movement right? Is the girl going to get eaten at the end?
Because she gets sleep, she's gonna get eaten because one brother
You're sewing doll clothes. Because I guess that's what people do. You are sewing doll clothes to sell at a crafts show. You have party dresses and casual dresses. Party dresses take 2.5 hours to make, while casual dresses take an hour. You make a profit of $9 on the party and $4 on a casual set. If you have no more than 30 hours available to sew, and you can make at most 15 outfits, how many of each should you sew to maximize your profit? So, as in SO, what is your objective here?
To make doll clothes.
No, what's your objective? Maximize profit. So, yeah, how much of each should you make? So, in this case, What's your profit on your party dress?
$9.
So $9 times your party dress plus, how much do you make on a casual set? $4 on your casual set. I'm sorry, I have to use the letter C for that. Is that all right? Is your objective? Well, I'll still use the big capital C for that. I'm just using because it's casual dress, okay? Your objective is to make the most money. You got to figure out how many of the party dresses you're going to make versus how many of the casual ones to make the most money. That's your objective function. Now, going back into that problem, they're discussing two other things. They're talking about time it takes and the amount that you can make total. Do you agree? So now you have to think about the time. If I'm going back into the problem, what's the most hours you can use? 30 hours. So your first thing you're bounded by is you have to work less than or equal to 30 hours. Do you agree? I like to always start with my total amount and work my way into the problem then. How many hours does it take me to make a party dress?
2.5.
And then how many hours does it take to make a casual? 1. There's one thing. You can write just C, that's fine. And then I do the next one. It says that you can make up to 15 of them, right? That's it. Most you can make, I believe it said. So that would be the same idea. It's a less than or equal to 15. And then what am I adding up together to get that?
C plus P.
Yeah. Now, can I make negative dresses?
No.
What quadrant will this be?
Reverse quadrant.
Once again, you have just created all of your constraints. What you're looking at doing is you try to identify what are the things you're looking for. What are the informations they're giving you? They're giving you something about time, they're giving you something about money, and they're giving you something about totals. Guys. Thank you. So let's split it and start plotting again. We agree that it's a first quadrant column. And when I go to get my intercepts, it's cover and solve. I'm going to do this again. I'm going to call this P and C, just because it's how I started with it and just keeping it going that way. 30 to 24. What's 30 divided by 2.5? 12. Thank you. 30 and 12. Is it going inward or outward from there? Inward. Good. And then the other one has intercepts at 15 and 15. Do you agree on that? Is this one moving inward or outward? It's inward again. So I'm assuming you guys can probably all tell right now that your region is in here. Does everybody agree on that? What's the one ordered pair that we have to solve for? The intersection of these two, right? So there's multiple ways to set that up, but you see how when I wrote it above one another, I can eliminate the C value by doing what?
Times by -1.
I can just subtract the 2. If I subtract these two equations together, I eliminate the value of C. And I get 0.5, no, 1.5, excuse me, is 15. Do you agree?
Wait, 1.5p?
Yeah, 1.5p, forgot to put that in. What I'm doing is subtracting those two equations together. I'm subtracting. System of equations. I have same coefficients, same sign.
Why do you have 15?
What's 30 minus 15? There you go.
Why did you do 30 minus 15? Oh, we're doing, okay.
It's the same thing we did last week.
Okay. It's just like G.
What's P? 10? So it's 10 and 5, and here is 0, 0. This is 12, 0, and that's 0, 15. All right, Butler? What do we got?
Wait, where'd you get the 5?
I'm just thinking.
What do you got? I got 5 because we solved this value of 10 to be P. So I substitute in here. 10 plus what is 15? Yes, sir. No. Thank you. So from those 4 ordered pairs, what one gives you your maximum profit?
0.15.
At 10.5? At 10.5 will give you your maximum profit. Do you want me to show you how to substitute back into your, I'm thinking you guys can do that. Okay. My guess is still getting to this part is what's going to be a little iffy. All right. I did forget to put the actual table on the next problem. I know. Let me give you the table to that.
That would kind of make it hard.
Yeah, it would. Here's the table. I didn't bring it up.
Yeah, I believe so.
There's the table for the bottom one, and I apologize when I was cutting and pasting these things because there aren't that many of these things in the book, so I had to try to make them, and I just.
It's all right, Mr. Murphy.
That'll be the table information for that last one on there. We'll let you guys copy that out before we get going. No, they're not important. I cut it on the wrong side. I wasn't paying attention. I almost lost a finger, and it would have been bad. You would have thought I was a shop teacher. Losing fingers? Oh, yeah.
I'm good to refine.
Yeah. Not good. So here's your objective for this evening. I know you're all freaking out right about now. You have this one to do, which is basically set up for you, and then 2 on the back. Okay. Yes, sir.
What does that say?
Production hours. It's talking about machine production, labor production, breakfast bars, granola bars, and the maximum hours. How many hours it takes to do all of them. Okay. Let me just pause this while you guys are finishing writing it out.